Hi all. So today we are going to see how to plot discrete signal in MATLAB. So we will take an example of sinusoidal wave. So when we consider a sinusoidal wave, so some of the parameter we need to define initially, right? So first parameter is frequency of sinusoidal wave, that is F. Let me consider it as 10 hertz. It means that we will have 10 repetition of sinusoidal wave in 1 second. If I consider here to here, this is 1 cycle and such 10 cycles in 1 second. Next is basically sampling frequency, Fs. So as per Nyquist rate, it has to be minimum twice the frequency of your wave. So actually, since our wave frequency is 10 hertz, it has to be 20 hertz. But let me consider a bit higher where we will get a clear sinusoidal wave without any sample loss, right? So let me consider Fs as 100 hertz. Okay. So when I say I'm plotting a discrete signal, then my x-axis will be n. Since like these are all discrete samples, and this n will be integer. Okay, and y-axis will be x of n, and here I am plotting sinusoidal wave, so it will be sine of 2 into pi into f by fs into n. Okay, so now here, right, like let me consider if I want to plot n thousand samples of sinusoidal wave, then what I'll do, it's like again I said it's n is integer and it has to be the incremental value, usually it has to be 1. So my n will start from 0 and it will go up to 1000 minus 1, because since 0 is also included in the sample, so I will consider 1000 minus 1, so total 1000 samples. So now I can just we will see like in detail how we will be doing that in MATLAB. So then I can just right away I can define a variable x of n equals to sine 2 into, so pi is an inbuilt function in the MATLAB, pi into f by fs into n. So this output will be again array, one dimension array, and which is of size 1000. Okay, so let's see how we'll be doing this in MATLAB. So let's initially define n equals to 0 to 999, total 1000 samples I am generating, and frequency I am defining it as 10 hertz, and sampling frequency I defined it as hertz. Now I will plot y equals to sine of 2 into pi is the inbuilt variable, you need not define explicitly, 2 pi f by fs. So let's put this in a small bracket in order to avoid, I mean like even if you do not put this bracket, it will take like precedency rule. Based on that, like it will interpret as f by fs, but like it's better always for your understanding to put some brackets. So into n. Now if you see n again, like if you see length of y, it's again 1000 samples, right? So like if you see the variable list, so you can see n and y are two variables, also like fs and f. This will be declared in the workspace, so you can see how, I mean, you can, if you double click, you'll see it is in a matrix format as well. Now let's see. Actually, we will define. Now let's plot. So here we are plotting a discrete wave, right? So for plotting discrete wave, in like in the previous example, in the previous video, we had seen like in order to plot a continuous wave, we use plot. Here we are plotting a discrete wave, so it will be stem. Okay, so stem like here like x comma y. So I'm plotting with respect to n and y, right? So now if you see this, let me zoom in a little bit, zoom out, let me zoom out a little bit. Let's see a few cycles of this wave. If you see here, it is like as we have seen, fs is 10 100 times, I mean, like 10 times we have given, right? So in each like each frequency duration, we will have around 10 samples. So we know that like 10 hertz means like it's a 10 repetitions. In 10 repetition, we had taken the factor of around 10, so we'll have 10 such samples basically. So this is like a kind of sinusoidal wave what you are seeing right now, right? So this is how actually like we look into the waveform, and also like you can give like as we had discussed in the previous example that like how we can actually represent the x-axis and y-axis, right? So let me consider x-axis as x label as n, and if you observe, n is declared, right? Similar way, if you change this to y label, and I need to mention it as of n, or you can mention as sinus. So this will be represented. This is how you plot a discrete wave, and like you can see, this value is also kind of like a discrete value, right? So for every n, so you can just click on this and just see like what's the value of any samples. Like if you zoom further, you will get a detailed view, right? So uh, here you can clearly see in one cycle we have 10 samples, because like our sampling rate was 10 times the position, right? So in that way actually. So this, I hope you understood this concept. If you have any doubt, please do let me know in the comment section. I'll be happy to answer those uh, comments. And like please do subscribe to my channel for like I'm planning to take all the DSP concept based lectures in this YouTube channel. Also, like I'm planning certain digital design and FPGA course channel. So please do subscribe and follow channel so that like um, I can provide more content related to digital design, DSP, as well as like even we can discuss 5G and artificial intelligence implementation in hardware. Thank you. Thanks a lot.